Welcome to our Industrial Arts Technology Lab. I'm Bob Beeden, Executive Director, and this is one of the programs that I oversee along with the teachers and the principals in the building. We're very pleased to be able to show you our Industrial Arts Technology Labs as we've been working on them since 1996-97 school year, where we actually started the implementation. Before that, we were kind of in a switchover mode where we were moving from the traditional industrial arts program, which included wood shop, metal shop, drafting, and electricity or electronics. Now we still do many of those things, but we do them in modules. What we do here is try to provide opportunities for students to learn about jobs of the future. Many of the jobs that we know traditionally are no longer there, or if they are there in title, they have changed significantly in the way they function. So we're trying to provide students with opportunities that will allow them to compete with anybody in the whole world. This has been a real teamwork effort, and I need to thank the instructors, both the current and past ones, who have been involved with this as we have evolved. We continue to try to update our modules. We're very proud of our students and instructors. We know that we help them in many, many ways to think about the future, and many times they don't even realize it, but the seeds that are being planted now through the use of these modules may well be an area that they would like to pick up and pursue after they leave high school.
In the Tech Lab, we look at the industry in a whole. There's manufacturing, communication, transportation involved in industry, there's the biotech industries, and all of that is covered here through different aspects, problem solving. As far as subject matter, we integrate science, communication skills, math. These skills that they do in their traditional core classes are used in here every day.
I call this kind of a career exploration. Students can come into this room, they sit down at a station called electricity or electronics or maybe engineering structures and bridges, and they find that this may or may not be a niche for them, something that they really enjoy doing. They get to discover digital video editing for the first time in the Tech Lab. They can actually build a bridge and check to see how much the bridge can hold, how much weight, how successful they are engineering. They can plan a family vacation and look at it on a map and see how many miles they've driven. In the digital manufacturing, they can actually program a computer-aided manufacturing machine to carve out their project out of styrofoam.
The things that are covered in the Wood Lab are they're focused in two parts. We have the students work with a design in a wood project, just like, for example, if they were to design a jewelry box, and then they would actually go through the process of constructing that jewelry box and finishing it off. The other thing is that we use it for the research and design of CO2 dragsters. It's important to use a wood lab for that purpose because they have to use heavy equipment like a bandsaw, drill press, and plus it's a competitive level for students, so they can see what each other are doing. So that's what we use the Wood Lab for.
The kids get to use a bandsaw to cut out their cars. They use files. They use a belt and disc sander. They use the drill press to bore holes. Along with many hand tools, we use coping saws, files, the list goes on.
In the wood shop, we take safety very seriously. We spend a good amount of time and instruct for good, safe work habits. We don't let the poor work habits develop. That'll follow them for the rest of their life. So we work on keeping our fingers from the blade, thinking the process through. We assess the risk. If the risk is too great, we don't do the step. We'll come up with a different way to accomplish that task.
What students build in the wood shop kind of depends on grade level. We start out with the basics because there's a lot of kids who may have never had any experience, and there are some kids who have done a lot of experience, a lot of experience at home, and so. In the 7th grade, we start with kind of one-piece type projects where you have one piece of wood, and we make desk sets which would have a pen holder, maybe a note holder, In the 8th grade, the main project we do is we build the CO2-powered dragsters. And that's a great project because there's a lot of physics involved, along with designing and creating the project. There's a lot of science we can put into that as well.
The CO2 races, we start with just a few math formulas. We talk about acceleration equals force times mass. We talk about a lightweight car. We talk very briefly about aerodynamics, and then we begin the design process. Students are instructed that, you know, that there are show trophies to be had and there are race trophies to be had, and they can kind of go down a path, or they can head towards both if they're really ingenious and engineering type students. And we work on some rough drafts. The students will come up with at least 5 different ideas before they get the official design worksheet. At that point, they can apply their drafting skills and lay out the car on paper. Once we get a good layout on paper, most of them will cut out the sheet and tape it onto their blocks of wood and begin cutting. We drill the holes in the back, sand down the cars, and work them from there.
We have actually limitations that they have to abide by to race in the district-wide race. Some of those would be the car cannot be shorter than 8 inches, no part of the car can be smaller than 3/8 diameter. So with that information, plus some information about aerodynamics, weight ratios, drag, friction, the kids come up with their own idea. And what they're trying to do is they're trying to make a car that will go as fast as possible down a 60-foot track.
So much more meaningful when the learning is hands-on and applied rather than just theoretical. They, like I said before, they get to actually do this. They get to manipulate and build the circuit and see the lights light up rather than just read about a complete circuit and even watch a teacher do a demonstration. They do the demonstration themselves.
At first, it's far more difficult for them in here because there isn't one textbook and the whole class isn't on page 13 at the same time. So when a question comes up, requires more research on their part, which they're not used to. You know, in a traditional classroom, when a teacher asks a question and they pretty much know they should be in the book and, you know, in this chapter. That's where the answer, because that's what they're studying. Here, it could be one of a number of textbooks or through an activity they were involved in the day before. So that's really causes them to use their learning skills more.
You know, in comparison to the other programs, I had students in 6th grade, they were running down the hall. And that was the most pleasant thing to see. They were running down the hall. They couldn't wait to sit down, log in, and start the process. And you know, that was the beauty of this program because it really draws the students here. They get to experience things that they sometimes only talk about in other class settings.